Here's a simple trig equation which involves finding the two answers for theta between 0 and 2 pi radians. Now in this interval, it's always the case that one of the two solutions involves needing the reference angle. So here's a method that will always give you the reference angle in one step. Since inverse, sine, cosine, and tangent always give out angles in quadrant 1 if their input is positive, I'm going to temporarily change this equation so that it's equal to positive 0.51, and by doing so you won't be solving for theta, but rather you'd be solving for the reference angle, which I'll denote as theta prime. So by changing the negative 0.51 to positive 0.51, I'm guaranteed when I take the inverse cosine of 0.51, the angle my calculator gives will be a quadrant 1 angle. Quadrant 1 angles are sort of special in that they are always the reference angle. So here's my calculator. I made sure that it's in radian mode. You may want to press mode and make sure that your calculator is in radian mode as well. If it isn't, scroll down a couple times, press enter to turn it into radian mode, click clear to get back to the home screen. To solve for theta prime, I'm going to take the inverse cosine of both sides. So pressing second cosine gives me the inverse cosine function. I type in 0.51 and it tells me in radians that theta prime is 1.0356 roughly. So notice that number from the calculator is not the answer to my problem. This is just the reference angle that I can use to find the two answers in the interval specified. In fact, it turns out that 1.0356 radians is a quadrant 1 angle, and in quadrant 1 cosine is positive, and we're actually trying to solve the original problem for where cosine is a negative number. So this cannot be the solution to the original problem. However, it'll be very helpful. So now what I need to do is consider what quadrants would cosine be negative. Well, it turns out cosine is negative in quadrants 2 and 3. So let's take them one at a time. Here's a picture just to remind you in general the relationship between an angle and its reference angle in quadrant 2. So we know cosine is negative in quadrant 2. What we have here, this 1.0356, is theta prime here, which I've denoted in orange. It's this acute angle here. Our job is to find the first angle, theta, which I've drawn in blue. So we need the amount of rotation it takes to get from the positive side of the x-axis to the terminal side of the angle in quadrant 2. And what we have is this little angle down here. Now we do know that straight lines are 180 degrees or pi radians. So one way to get theta is to take pi, which I've written here, which would be the amount of rotation to get from the positive side of the x-axis to the negative side of the x-axis. By doing so, you've gone too far because we only wanted this blue amount of rotation, if you will, and pi radians is a little bit too far. So what you have to do is take pi radians and subtract theta prime, which I've denoted in orange. If you take pi and subtract off theta prime, it'll give you theta. So I'm going to do that now. So second caret gives me pi. I'm going to subtract. You can either press second negative to get the previous answer on the calculator, or if you have a newer calculator, you can go up and press enter and just copy it down there. So one of my answers is 2.1 radians roughly. And if you want to verify that your answer is correct, we could plug that angle, 2.106, into the original problem. The original problem says find an angle, theta, so the cosine of theta would be negative 0.51. So if I say cosine of this answer, which I'm proposing is the correct answer, we can prove it's the correct answer by taking the cosine and seeing that it's negative 0.51. Now it didn't come out exact because of rounding, but you get the idea. Now there's one more answer to find because the question said find all angles theta between 0 and 2 pi, and we've only found one of them. The first answer was 2.106 roughly. So it turns out that cosine is negative in one more quadrant between 0 and 2 pi. That would be quadrant 3. So let's take a look at the relationship between theta and theta prime for an angle in quadrant 3. If you're in quadrant 3, the amount of rotation that it takes to get from the positive side of the x-axis to the terminal side looks like this, which I've denoted in blue. That's the actual angle that we're solving for, theta. What we found here was theta prime is 1.0356. So now if I want the amount of rotation denoted in blue, the actual angle, I would have to take 180 degrees, or in our case, since we're using radians, pi radians, and I had to have to add on this amount of rotation here denoted in orange, which is our theta prime, 1.0356. So back to our calculator. This time I'm going to do second caret and do pi plus our reference angle. You can either press second enter 1, 2, 3 times to get all the way back here to this answer, or if you have a newer calculator, simply scroll up until you have the number you want and press enter. So our second answer, also a number between 0 and 2 pi. Remember that pi is roughly 3.14, so 2 pi would be 6.28. So this number is definitely less than 6.28. It's a number between 0 and 2 pi, and it has the property that if we take the cosine of it, we should get negative 0.51. Again, since I'm proposing this as our second answer, we can plug it into the original problem to verify that it works. So I'm going to press cosine, and I'm going to go up and grab our proposed solution, press enter, and verify that it also is a solution, negative 0.51. And again, I'm seeing a little bit of round off error, but I'm not too concerned there. So hopefully this gives you a method of quickly finding theta prime for any simple trig equation of the form either sine theta equals a constant or cosine or tangent theta equals a constant.